So good morning to everyone that's present here in the room, and good morning, good afternoon, good evening to people on the camera, wherever you may be. I wanted to take this opportunity to welcome everyone here at Cambium Networks on a very special event. The event today is the official launch of the ePMP 2000 product, which is part of the ePMP product family from Cambium Networks. We're very excited to have you here in the room as well as attend online. The goal of today's event is we're going to share our vision on why we created the ePMP 2000 product. All of you joining offline or online are involved in the wireless industry. Whether it's unlicensed, licensed products, backhaul, you are in the wireless industry. So it's important for us to share our vision why at this juncture we're releasing a product that is ePMP 2000. After that, we will talk about what is ePMP 2000, what makes it unique. We're going to go through a little bit of a technical explanation as well as share the key components of ePMP 2000. The last piece you'll notice is we actually have some equipment that is static here, but there's also some radios in the back of the room. I will go through a video of a demonstration we held in this room, and the original intention was to hold the demonstration live with you guys, but as you can see with the overhead projector, it's a risky business. So we did do the demo here. We captured the video. We'll play the video, and I will talk through what you are seeing in this video. And that is sort of the agenda. Tail end of it, we will ask one of our customers who was involved in a beta eVergent in our nearby neighborhood, and they used the ePMP 2000. I will ask them to come up, speak about their experience and what they've seen, and we will finish it with a Q&A. The Q&A, we will allow questions in the room. We will also take some questions online, but I also want to highlight that whether you're in the room or whether you're on camera or watching the show, our community is a great place to post questions that you don't get answered today. And we anticipate that with a new product launch, you're going to have tons of questions. And we highly encourage social media, community forums to feed your questions into Cambium. And we'll be paying extra attention post this launch to give you that background. So with that, as I was saying, why ePMP 2000? So, this, I believe, is a view that many in the room have and many in the audience have, is that in today's day and age, we're seeing more and more equipment going up in the air of different technology, equipment that's requiring more channel bandwidths. The amount of 5 gig equipment beyond our dual band phones of iPhones and Samsungs is unprecedented. Which leads me to the next point, that as you do spectrum analysis, whether it's in your home network or whether it's in your remote network and whatnot, it's gotten to a point where finding a clean chunk of channel, forget 80 megahertz, 60 megahertz, just finding 20 megahertz and 10 megahertz becomes an issue. And we all know that the bandwidth demand of the customers are going up. And there are other parts of the world, and I speak to the audience watching, in some other parts of the world, even getting 5 megahertz and 10 megahertz becomes a challenge. And where the basic connectivity needs are very different from the audience sitting here in the room, which is North America centric. People are looking for 5 megabits per second, and they'd be happy to get that, and they're not able to. I've seen some towers, and I look at our friends at eVergent. Your tower actually was quite congested. But I've seen some other stuff that is mind-boggling. I've actually seen a tower that apparently fell over because of the amount of equipment that was put on it in Southeast Asia. I won't name the customer here, but there's unprecedented amount of equipment on these towers. Or you look at a rooftop building. We fortunately enjoy some regulations and things like that. Some parts of the world, maybe it's not enforced as strongly. So you see a little bit of a crazy deployment model where there's lots of gear coming up on the tower. And the reason I'm highlighting this is that the product we're talking about today, ePMP 2000, is very relevant for these environments. So if you live in that environment, you're running a business in that environment, the word interference is strong in your vocabulary. You think about that. That's your daily life. And we are giving you a product that addresses that problem at a price point like no other in the industry. So that is the essence we're going to get to in a second. The last piece that I do want to point out, we want bandwidth. Everybody's asking for more bandwidth. We have products in the space today that is saying, from other vendors, take your 11 AC type product that's designed for indoor, let's go put it outside. I'm going to get 300 megabits per second, but you're getting that at a cost. And the cost is you need 80 megahertz of channel, 256 QAM modulation. Goes against what reality is. You are not going to find that 80 megahertz, and if you do, you're going to be challenged to find it in a clean way so you can maximize your throughput. So that is actually a problem. So if you're going to do an investment in future platforms, you want to do in products and platforms that can maximize the performance with what you have. So I'd like to say that we at Cambium are trying to position our products to give you more for less, instead of saying, hey, just go find more spectrum and dirty up the air even more. This picture doesn't come across well, but that is actually one of the example rooftops I was referring to. It's got a lot of gear, and I've actually seen some that are worse than this, and I'm sure some of you on the online screen as well as in the room have seen things like this. So what I consider a real problem is that interference is your real problem. And that is the message I want everybody attending the session to walk away with. That we are here to address your most basic problem, which is dealing with interference. This ePMP 2000 product, before we get confused with any more information, I want to state this very clearly. Backwards compatible. And when I say backwards compatible, any ePMP subscriber module that you have in your network will interoperate with ePMP 2000. ePMP 2000 is an access point only. It's not a subscriber module. So you simply replace what you have today, or you add this to a new tower, new location, and you use the same subscriber base that you have today. We are obviously a wireless company with years of experience in wireless deployment. Actually, I should say creating wireless products, but the deployment experience comes from you guys. But as we explore and visit customers, whether it's on-site troubleshooting or remote troubleshooting, the two things that we see more than anything else is interference that's coming from adjacent channels, neighboring channels. So when I show that tower with lots of equipment, that means every piece of equipment out there is screaming loudly, right, in their own channel. It may be 60 megahertz away, it may be 100 megahertz away, it may be 300 megahertz away. And some people are putting up giant dishes. And this may not be applicable to audience in the room, but the rest of the world, I've seen scenarios where towers are filled with big dishes and people are overcoming their problems by screaming louder. So when you're screaming louder, you are creating interference for the access point that's next to you. So that's what I cover in terms of saying adjacent channel interference. And that adjacent channel can be 100 megahertz away, 200 megahertz away. And depending on how loud it is, it will impact your performance. The next thing is co-channel interference. Co-channel interference is I'm on a channel, I'm screaming, and somebody's screaming back at me on the same channel that is not my network. Meaning your current channel that you're on is very polluted and crowded. Probably a very relevant scenario. So we look at these two problems as the primary source of interference. So can we solve this today? Can we give you a product that is relevant and addresses these two problems? Yes, we can. And that is ePMP 2000. I also want to make sure that everybody walks away that we're solving problems in the uplink. And there will be questions following this event. People say, why didn't you do it in downlink? The experience that we have gained by deploying wireless equipment and working with our customers and partners is that that picture I showed with the rooftop full of equipment, that means if I am the rooftop and everybody in front of me are subscribers and other networks, they're all talking to me. And if the rooftop is crowded, it translates to a tremendous amount of uplink interference. So solving uplink is a significantly bigger bang for the buck than solving downlink. Because downlink at the end of the day will be subscribers at different locations that may not necessarily have high power dishes right around them. I'm not completely discounting downlink, but the benefit in uplink far outweighs the benefit in downlink, and therefore ePMP 2000 as a product addresses the problems in the uplink. Right. So that essentially talks about why we brought ePMP 2000 to the marketplace and what the fundamental things it addresses. So with that, we will transition to what makes up ePMP 2000. And this is something important for the audience here as well as on the camera, that to understand the components, understand some of the features. And with that, we're going to transition off to Alex Marcham. Alex is a product manager for Cambium who recently took over the ePMP product line. So Alex, I'll let you take over. Thank you.
Thank you. Hi, so I'm Alex, the ePMP product line manager, as Keith just mentioned. So what is ePMP 2000? So ePMP 2000 consists of three main components, first of which is the ePMP 2000 access point here. So this is a next generation ePMP access point, backwards compatible with all current ePMP 1000 SMs. Building on the kind of feature-rich performance and scalability that you expect from ePMP 1000 with 120 SMs, maximum registered at a time, frequency reuse via GPS sync. It's available in a light model, which has the same 10 SM restriction as the ePMP 1000 Lite AP, and is also available in full models with a license key upgrade from light to full, if you choose to do so. It's got an 802.3 AT compliant gigabit Ethernet port and a very wide frequency range, as you can see there, from 5.1 to 5.9. So, following on from Sakit's point about how we deal with co-channel and adjacent channel interference. So, intelligent filtering is a capability built into the ePMP 2000 access point, which is made to deal with adjacent channel interference, so see anything other than co-channel interference. Smart beamforming is available in the optional ePMP 2000 smart antenna here, and helps to protect against uplink co-channel interference. We've branded these under the umbrella term of HiPure to kind of encompass all the innovative technology in ePMP 2000. So those two parts make up that whole. So for the pricing, the ePMP 2000 access point is priced at $599 for the full 2000 AP and $309 for the light AP with the 10 SM restriction. The upgrade license to go from light to full is just the difference between those two prices. So there's no penalty for buying a light and then upgrading to a full. And the optional smart antenna to get the uplink beamforming capability, or smart beamforming as we're calling it, is priced at $399. So there's one other component to the ePMP 2000 system that we're introducing today, which is the new ePMP 5 GHz sector antenna here. So benefits in the new sector antenna are, for frequency reuse deployments, we have a very high 35 dB front-to-back ratio, which is much higher than comparable antennas in the same price range and market. We have consistent gain from 4.9 to 6 gig across the whole band. Null fill has also been implemented very well in this antenna, so that subscribers close to the antenna aren't excluded from the coverage range. Whereas in other antennas, if you're too close to the antenna, you actually can't get a signal, whereas you think it would occur further out. So it's designed for the installer with a small, compact design. You can see the 1000 AP antenna here compared to the 2000 AP antenna here. So compact design, integrated mounting for the 2000 and 1000 APs, and integration of the GPS antenna. So a cable runs from the side of the AP mounted on the back up to place the antenna in the top here, so it's integrated in the mounting. And it's also integrated into the link planner, so you can have confidence when you plan your network with this antenna. So just to show you how it all fits together, so you can see the AP mounting to the back of the sector antenna, the beamforming antenna or smart antenna connecting to the bottom of the sector, and then the sector screwing to the back there with the optional tilt at the top bracket. And these are just a few more views to show how it's physically set up. You can have a look at the actual physical setup after the presentation, but just so you know how it all plumbs together. So at this point, I'd like to bring up Dan Sullivan. He's the ePMP Software Development Manager to talk a bit more about how the product works. Thank you.
Thanks, Alex. Hi, I'm Daniel Sullivan. Provide the system architecture and software engineering for ePMP. So, how does it work? We're going to talk about two key features that help to protect both the adjacent channel interference that Sakid talked about and the co-channel interference that Sakid talked about. Often we have spectrum, as you know, and unlicensed, and it's congested for most of us. We don't live isolated from other people. We live integrated with other people so that we can do our daily business. And some of the channels are better than other channels. So in traditional RF planning, we choose the cleanest channel that we have. With a regular radio or typical radio, we have fixed filters. They're static. They cover a certain range, and they protect us from interference that is in the area of the filter. What happens, though, is there is interference right next to the actual channel that we work on. And these filters don't protect against that. So what we've done in Cambium is we can use an intelligent filter to address this neighboring interference. Here, we might have a selected channel that we decide is the cleanest like we had before. With our intelligent filter, though, it wraps around the selected channel and thus protects us from the interfere that we see with the traditional filters that we've used in the past or other radios would use. The filter is dynamic. So if you decide you want to change a channel for any reason, not only does the channel change, but your filter changes, providing you the same protection that you've had in the past. So much like the example Sakid gave, where you have all of those other access points on the rooftop, you can go ahead and use our radio with more confidence to protect yourself from these other interferers that are located nearby. Let's talk about smart beamforming, the second feature that we have. You can see here that we have three parts to this ePMP 2000 system. We have the actual ePMP device itself mounted behind the sector antenna, the new sector antenna that is used with ePMP 2000, and we have the smart beamforming antenna, the smart antenna. Here we see that we have an access point that's talking to 3 subscribers, and there's an actual interferer pointed towards the access point. When the subscribers talk with the traditional sector-only approach, what happens here is that the access point is hearing the interfere at the same time. So here we have a co-channel interfere that when it talks, we hear at the same time our signal talks, and it degrades the overall performance that each of the subscribers would like to have. But with smart beamforming, with the smart antenna, even with the co-channel interfere there, we direct a beam towards the subscriber on the uplink. So when that subscriber is talking, like the top subscriber now, it will have a better, it still hears the same, that subscriber just as well, or even maybe a little better than the sector antenna, but now it's deafened towards the interfere, and that helps your overall carrier to interference noise ratio, which makes you have a better overall signal for your subscriber and better throughput. When the second subscriber is used, just like in any ePMP system, where on all the time we're dynamically switching between subscribers, and they're very closely separated from each other in time, we actually switch the smart antenna beam at that same moment. It's all coordinated. So you get increased performance for all the subscribers that are working with our new smart antenna system. Okay, so with that, I'll turn this back over to Sakid.
Okay, thank you, Dan. So before we go into the demonstration video, I want to bring us back to a point we're coming across with here. You've seen the two key features. You've also seen the price point. So one of the messages I want to convey at this time is if you think about beamforming, the technology has been around for a while. We hear it in indoor Wi-Fi radios and things like that. Some products out there do have beamforming. But typically, from what I hear or what I see, beamforming products' price ranges are significantly higher than what we're offering with ePMP 2000. So combination with the filtering we're building in to help with all the noisy, loud guys left and right of you, and you add the optional beam steering antenna, you get our sector antenna. List price of $1,000 gets you everything you have in ePMP today, plus these two very nifty advanced features. And this wasn't just a feature we developed patching up together. There's a lot of development effort, algorithms, and inventions behind the scene that makes this work in an outdoor environment. So walk away with this today, before I even show the demo, that for $1,000 list price, we're giving you an ePMP 2000 platform, optional beamforming, a new sector antenna, all that we consider best in class for the marketplace. And most importantly, very, very relevant. I could have saved this for the end of the session, but I'm going to repeat this again at the end. So, all right. So the demonstration is actually a video. So if you excuse me, I'm going to play this video a bit and speak to you at the same time. I'll let this thing play through, and maybe when it stops, I will explain what we have done here. So as you can see, the video itself is in this room. Sorry. The video is in this room, and the ePMP 2000 access point, ePMP 1000 access point, were more or less exactly where you see it. We kind of panned over it quickly, but it was here. In the back of the room, which you see today, a slightly different location, I'm going to pause this video right here and rewind it a little bit. Okay, we'll stop here. In the back of the room, we have the ePMP subscribers. So the conditions we're trying to build are two situations. One, how do I create an environment in this room without fancy lab equipment, with just ePMP product, that mimics that loud, noisy guy left and right of you? Okay? So what we did in that case is we took some baseline data, which is the ePMP 1000. What does that do in that condition? And what we did was take one of our Force 180 subscriber modules, convert it to an access point, which you know we can do, and ran it in what we call a continuous transmission mode, something we do to calibrate the product in factory tests and things like that. We're able to do that. But what that mimics is a neighboring radio screaming loudly and constantly. So that represents a adjacent channel. And in this case, it was approximately 100 megahertz away. Power levels were pretty high, something you would see on a tower. So the Force 180 subscriber is screaming really loudly, sitting next to the ePMP 1000. The next scenario, which is depicted in this, is where the pink reddish color is the same Force 180 subscriber. Instead of being 100 megahertz away, is only 5 megahertz away from the center frequency of our victim product, which is 1,000, and then we repeat the test with 2,000. So now what happens is as the ePMP 1,000 or 2,000 is talking on the same channel, you've got a Force 180 subscriber screaming back. Same channel. So this is now co-channel. And you take the baseline data with ePMP 1000, then you take it with ePMP 2000, and then you enable our beam steering antenna for the second scenario. So summary of this demo is we create an environment where there's a screaming adjacent channel subscriber. We compare data between a 1000 and an ePMP 2000. No beam steering, no beamforming, none of that is in play because the filtering comes with the ePMP 2000 as it is. How does that data compare? Then you enable the co-channel, include the beam steer, and see how that data compares. In all cases, this is networked, connected to the Cambium network, and to a speed test server. So there is no throughput limitation. We're not doing UDP tests, we're doing TCP tests, because that's what's relevant for us out there in the real world. So that is the test scenario. So I'm going to keep playing this video, and it's going to fast forward, and I will give my commentary as this plays. ePMP 1000 baseline setup, just pure simple test with the subscriber on the other side of the room, 20 megahertz channel, and we're fast forwarding to the speed test, by the way, but 1K baseline, very nice. So that's ePMP 1000 now doing a co-channel where this interfering radio is blasting away at the ePMP 1000. And the same test, just throughput test, ePMP 1000 is struggling because now a subscriber is talking back to it, that it's not his. So it's the co-channel interference. And you just noticed, and I'll do the summary slide at the end, but the throughput drops significantly. Now the same ePMP 1000 with a screaming subscriber next to it as a neighboring channel. And you notice the uplink once again is impacted. Now we go to ePMP 2000, same test, same victims. This is just a simple baseline of ePMP 2000. Fortunately, those on the video can pause and stop and watch this again, and this will be available for everybody in the room as well. If it's too fast, you can watch it at a later time. But now with the ePMP 2000, we're also introducing the same channel interference. That's the number, the 41 megabits per second as opposed to a 5 megabits per second on ePMP 1000, because the beam steer is in play. And now, and we'll go to the summary, and as we go to the adjacent channel, 84, 85 megabits per second as opposed to 50 megabits per second. So 30 megabits per second improvement, and this is where I will pause it. Okay. So let's take a look at the summary data. And this is where I will grab my laser pointer. I knew there would be use for this. So baseline test, downlink 94 meg, uplink 85. 1K represents ePMP 1000. When I fired up another, let's just say, subscriber, talking right back at the 1000, remember, we are solving an uplink problem. This is all mimicking challenges in the uplink. When that happens, your uplink speed goes from 85 to 5.7 megabits per second. This does happen. This is not a made-up situation. Maybe not exactly 5 meg, but a variation of this does happen in the field when there's strong interference coming on the same channel at the access point. Power levels will vary based on distance, obstruction, things like that. But people do suffer from significant uplink throughput degradation in these types of scenarios. Then, when we have an adjacent channel, this is the congested tower. Somebody is to the left of me, screaming loudly. The drop is not as bad, 51 megabits per second as opposed to 85. Speaking to people on the Internet, there are towers in the world where the neighbor next to you is a giant dish, which means their power levels will arrive very significantly stronger, and that 51 can actually degrade even more. So it all varies on how loud the person next to you is screaming. Then when we do ePMP 2000, these are the numbers you compare with that row to this row, and that comparable. And in co-channel, when the beam steer is enabled, what's happening is your 5.7 recovers up to 41 megabits per second. And this is what Dan Sullivan showed a second ago. Walk away from this session thinking about beam steering as I am talking, somebody's talking back, but I am able to direct how I listen. I have like a megaphone or something that creates directionality to the person I'm speaking to and cuts away the noise that I don't want to listen to. That's what's giving you that jump. That jump from 5.7. This is a test we did in this room with real equipment. You can do this in your lab, encourage your customers to try it if you're a distributor or a partner, but this is real data that validates this solution. And we also have betas and trials where we are seeing this improvement. And when the ePMP 2000, and this is a very interesting data point, when the ePMP 2000 is seeing the same interfere left or right of it, there's a 35 megabit per second improvement. Now here's the beauty of it. This is ePMP 2000 in its basic form. No beam steering needed. That subscriber or access point left or right of you could be 100 megahertz away, 150, 300, 400 megahertz away. It doesn't matter. As long as the signal is somewhere like negative 30 dBm or higher, we completely go deaf. We don't listen to any of that. So it's cutting out. In other words, what we call blocking performance of this radio is significantly superior to anything else. And this you get with 2000 by itself. So while beamforming is great for co-channel, if you want to use the beamforming as an optional accessory, because maybe your co-channel interference is not terrible, you get some benefit just buying the 2000 as it is. And that's the essence of that. Okay. We will move ahead and introduce Joe Falaschi and Bayan Deanparver. They are from eVergent Communication. Gentlemen, a little bit of background. eVergent is actually throughout Wisconsin as well as Illinois, so close to our headquarters. So we engaged with them to do some beta trials and provide some equipment. And with that, I will stop and let you guys speak. So please.
So my name is Joe Falaschi, and just a short intro on eVergent. We're a wireless ISP. We started a little bit before 2003 doing wireless, transitioned from dial-up. Our business really took off when we started doing Canopy FSK. And right now we sit in the area between Milwaukee and Chicago, about 60 miles north-south and 60 miles east-west. And that covers a pretty varying degree of environments, very suburban areas where we have residential customers, rural areas where we have residential customers, and then we have business parks near like O'Hare Airport where we have a lot of business customers. And the uplink becomes very important in those business environments where we found a sweet spot of fitting in between the fiber carriers. And so if you're looking for a 12 by 12, 24 by 24, where we need to do that higher bandwidth uplink, in some instances that becomes a little bit of a challenge. And so that's why we're excited about this product. Maybe Bayan can talk about our specific deployment and how our trial with this product went.
Hi, I'm Bayan. Just wanted to let you guys know I came in 9th place in the Helen Keller School of Public Speaking. There was a class of 10. Just thought I'd break that in. Nobody said a joke here so far. So, yeah, we like Joe said, we're in Wisconsin, we're in Illinois, and we through some acquisitions, came into suburban Illinois where it's very congested and it's very noisy, and which is kind of like not what we were used to seeing in Wisconsin. So with the acquisitions, we were migrating some of the customers that were already on these towers from other equipment to we're trying to upgrade them so they can get more capacity, and as you all know, the bandwidth demands are getting greater and greater. So when we put up the access points on the Chicago's suburban areas, we started seeing all sorts of issues. We knew that there would be noise. We knew that we had to deal with them. We just had no idea how bad the noise really was. Where I'm sure for you guys that actually deployed a network, you kind of go in, do your spectrum analysis, choose your cleanest channel, kind of like what Keith said. And I know the ePMPs and such have the automatic channel selection, but nobody really uses it. I mean, it's, you know, you want to choose your channel. Well, the noise floor was so bad that we couldn't really choose a channel. I mean, we just like have at it, pick whatever channel you want radio, because it really wouldn't matter what we did. And therefore, we were converting the customers, hoping that once we decommissioned the older equipment, these radios would perform better. Well, some of the problems that we ran into that we didn't even expect was loss of GPS sync, which these things all have GPS antennas. So this is what triggered our communication with the folks at Cambium saying, help us out. We don't know what's going on. Why are we losing GPS antenna? Well, from the neighboring end, this is one of the towers. There's so much noise on there that it was interfering with our GPS signal, and that's why we were losing GPS sync. So we opened the channel, we asked them, and they're like, hey, let's try these things out. And we tried some other GPS pucks. It helped a little bit. So they said, we have this new product, try it out, see how you like it. They came out, we went to Wisconsin, we met with Dan and another one of the engineers, and we put it up on a tower in Wisconsin, nice clean area. My house was on it, which was a bonus. And we tried it out, and we kind of went through some of the things that you kind of run into when you try a brand new product, and those all got squared away. But in Wisconsin, it's kind of a cleaner environment. So we said, let's go deploy it somewhere where, I mean, we can really try it out and heat it up and see how it really performs in the real environment. So we went up. This is a tower out in Lake in the Hills, Illinois. We already had a full cluster of ePMPs. We took one off, put the ePMP 2000 on. Like Sakit said, they're backwards compatible, so all the existing customers on that sector connected immediately. And we kind of took screenshots and took some data prior to moving the customers over. I should probably back up and tell you that the problems we were seeing, that the customers were getting great download speeds. They're all like within a mile or two of the tower. The modulations were great. They were all at the highest modulation, pretty close, like 14 to 15, 12 to 15 download modulation on the MCS levels. However, the upload modulation was pretty bad. I mean, it was anywhere between 2 to 8 MCS levels on the upload. And I had yet seen, and I'm pessimistic when it comes to new products, some of the people here would tell you, I had yet seen anything in the 802.11 line that deals well with interference. I mean, there's ubiquity out there, there's all sorts of things out there that we just haven't had good luck when it comes to high-level interference. And we put this up, and I was expecting the MCS levels to go up. And I was like, okay, so they got the intelligent filtering, that's great. They got the beam steering, that's great. We'll put that up. And sure enough, they went up. They went up by quite a bit. What blew me away, and I was on a tower, and Joe was on the ground when we were doing this, along with one of our other technicians up on the tower. They kind of flew the drone around and took video. And the downlink power levels on the customers went up by like 10 to 15 dB. Now, mind you, it's the same gain antenna between the ePMP 1000 and the 2000. And that's just one thing I didn't expect. So people that were that were connecting at 65, 66 dB power levels were all of a sudden sitting at 55, 53 dB downlink. And in addition to that, the MCS levels went up by 5 or 6 modulations. So I was quite pleased when that happened. So far it's been working great. We haven't had really any issues with it. We haven't lost GPS sync, which is great. And I can actually choose what channel I want as opposed to just having the radio have free reign on whatever it wants to be on. So that's kind of what we saw.
Thank you, guys.
Sure.
Thank you very much for that testimonial. Thank you.
Thank you, Joe. Thank you.
All right. So that was exciting. We didn't have any prior collaboration. Trust me on that. So with that, I have some questions in my hand that came in from the audience online. But we are going to shift. We're running a little ahead of schedule, which is always good. But I'm going to start with some questions in the room. So if you guys have some questions, we'll take the questions. Alex is here. Dan is here. We have some hardware team members, Dimitri. So we can take some questions. Then I'll respond to a few questions that came online. So, or comments. I'll take comments too. Anything in the room? Yes.
The sector antenna, that's a 90-degree sector, and is it available in any other form?
Right. So it's a 90/120. It can do both. And any other form, as in, you'll probably look in 60.
Like 120 or even 60. Yeah.
So 90 and 120, it will support. 60, it does not.
Okay.
So it's available in 90 and 120 today.
And the beamforming antenna below that is similar then?
Right. So beamforming is creating beams dynamically. So it's trying to create patterns within a 90-degree framework. So it's best that it works with a 90-degree sector. If you go any wider than that, the benefit of beamforming will be limited to the area that it can maneuver within.
Could you just repeat the question?
Yes. So the question there was, actually it covers one of the questions online. The question from the audience was if the sector antenna did 90 and 120, or if it also did 60. And the second question was about the beam steer antenna, on whether that covered a certain sector pattern or a beam width. And my answer to both of those were that the sector is 90 and 120. We don't have a 60-degree today. And the beam steering is best to go with a 90-degree sector, as it does beamforming within a 90-degree pattern. Any other questions in the room, please?
The filtering system, is that based on a new hardware chip that's in front of the radio hardware chip, or is it software-based?
The question was if the filtering is based on a new hardware chip that sits in front of the main chip, or if it's all software-based. The answer to the question is two parts. One is the ePMP 2000, we did go to a new chipset in the family of .11n chipsets. But the front end that enables all the filtering is all hardware-based. It's not a chip per se, but it's our own design, proprietary design, but it's all hardware. Any other questions in the room? Okay. If not, I will see if I can answer some questions that came online. A question was that we are 100% solar. What is the voltage power consumption of ePMP 2000? This is going to come up quite a bit, I assume, about power questions. ePMP 2000 will consume about 15 watts of power. It comes with a 802.3 AT power supply that's capable of up to 25 watts. So the number you walk away with is about 15 watts, and I hope that's the answer that helps the audience in the internet. Very important question. When will ePMP 2000 be shipping? We are taking inventory out of our factory as we speak, going into our Shanghai distribution center. Many distributors around the world have already put their orders in. So now the gear is going to get on a boat, and some will get air freighted, and it will start going to our primary partners within 4 weeks or 6 weeks. So we will start seeing product permeating in the market early July. Another good question. Will ePMP 2000 replace the ePMP 1000 product line? Absolutely not. Remember, ePMP 2000 is a new access point. So first of all, none of the subscribers you touch. Secondly, the primary flagship product of ePMP 2000 or ePMP portfolio to date has been the ePMP GPS AP. Frequency reuse at that price point is the big story for the ePMP platform. That product still survives. It's still available. It is absolutely a viable solution for many, many deployments. Because you're dealing with frequency reuse, you have some interference. 2000 is when you get into the really challenging environments. So 2000 is meant to complement 1000. At the same time, if you're putting up a new tower, and there's the potential, as we all know it, in a year, 15 months, 16 months, more stuff comes into the air, you might as well consider something that can future-proof your investment. Last question. Can ePMP 2000 use a third-party antenna? The answer is yes, it can. We highly recommend you only buy the Cambium antenna, but it can be. The 2000 unit does come with a pole mount bracket that ships in the box. And those of you in the room can answer the right questions. You can get a box and open it for yourself. But it does come with a pole mount bracket, so you are able to use cables that we recommend on our forum to connect to the beam steering or a third-party antenna. So, those are the questions. Anything else in the room? Yes?
With the beamforming antenna, I'm assuming there's another set of RF connectors on the bottom of the radio to connect the beamforming antenna, so you'll have a total of 5 RF connections off the radio, including the GPS.
I'm just going to repeat your question. The question was that the beam steering, the ePMP 2000 unit, has 2 extra set of connections to connect to the beam steering antenna. And therefore, if you take the sector connections, beam steer connection, and the GPS connection, there's a total of 5 connections. The answer is yes. That is correct. Okay. If nothing, yes, please.
Is there or will there be any compatibility with third-party brands, like other brands, so that I could migrate my actual network to ePMP?
Right. The question was, will there be any type of migration mechanism to take a third-party equipment network to ePMP? Today, the answer to that question is you can configure an ePMP access point, whether it's 2000, 1000, in standard Wi-Fi mode. And you can also configure third-party subscribers to standard Wi-Fi mode. And you will be able to connect in standard Wi-Fi mode. Once you connect, then you can switch the mode of ePMP to the proprietary mode, right? And then start replacing subscribers. So standard Wi-Fi is the way to migrate today. Yes?
Is the mounting scheme safe such that you could take an EP 2000 and mount it on the back of the old sector?
The question was if the mounting scheme is the same, where you can take the ePMP 2000 and mount it on the back of a ePMP 1000 sector antenna. The answer to that is no. We have not created a mechanism to mount the ePMP 2000 very easily to the back of the 1000 with any bracket. I will say this to you, though, that there are partners in the ecosystem that have built brackets, and we are looking at options of creating and helping a partner create some type of bracket that can go on the back of a 1000 so 2000 can mount on. So I am pretty confident you will see something like that soon enough. Any other questions? Okay, sure.
The RF filtering, does that help at all on the transmit and therefore your own interference with main range?
Right. Very good question. If the RF filtering helps with the transmit at all, and therefore does it make the radio quieter and frequency reuse benefits? The answer to that is yes, and we should have talked about the transmit side a little bit. But when we talk about this filtering, if you compare an ePMP 1000's transmit mask and if you compare an ePMP 2000, it is quieter, meaning it doesn't spread out as long, it cuts off nice and sharp. So there is a benefit to that as you put up ePMP 2000. Any other questions? Okay, so if no other questions, we can stop with our video broadcast session, and what I will do is we'll shift to a quick raffle of sorts.